So if we've got a right-angled triangle, which looks something like this, okay, and we make sure we denote that with our little box in the corner there, then the Pythagorean theorem says that a squared plus b squared is equal to c squared. Okay, what does this mean? Well, first we've got to understand what A, B, and C are. So A, B, and C are our sides of our right-angled triangle. And there's a couple of rules that we've got to follow when we're denoting which side is going to be which. Now, C here, C is always our longest side. Okay, or in other words, we call this our hypotenuse of a right-angled triangle. Okay, and that's always going to be the side that is opposite to that right angle there. So this side over here would be our side C. And then sides A and B, they're our shorter sides. And we can decide which one we want to be A and B. It doesn't really matter. So I'll make this one over here A and this one down here B. Okay, but again, you could have those two the other way around. That wouldn't be a problem. So what does the rule say? Well, Pythagoras' theorem says that if I take whatever this side length is here, okay, A, and I multiply it by itself, and I add that to this side length here, B, and I multiply that by itself, then that is equal to c squared. So if I was to take this side over here and multiply that by itself. We'll see that in an example now. So let's have a look at an example. We've got a right-angled triangle here, and this is right-angled by that little square in the corner there. And we'll say that this side length here is 4, this side length here is 3, and I want to try and work out what this hypotenuse is here. So that's going to be my C. Well, the rule is that a squared plus b squared is equal to c squared, okay? And I can choose which one of these 3 or 4 I would like to be A or B. So I'm going to have my number 3 as my A, and I'll have my number 4 as my B, and my C is always my longest side. So what we do is we take our equation and we substitute in some values. So we know that A is equal to 3. So I can write 3 squared here. And then instead of B, I can write 4, so I get 4 squared. And we're not sure what C is. That's what we're trying to work out. So that is equal to C squared. So I can simplify this down. I know that 3 squared is equal to 9. And I know that 4 times 4 is equal to 16. And that's going to be equal to C squared here. And I can continue. 9 plus 16 is 25. So C squared is equal to 25. So I need to think of a number that multiplies by itself to give me 25. Okay, and if you think about it, you could potentially see that C would have to be 5 in this case. 5 times 5 gives me 25. Now, it's not always going to be that nice, okay? We're not always going to get these beautiful square numbers. So what we can do is we can take the square root of both sides. So if I want to get rid of that squared term that's on my C, I can take the square root. So I would do the square root of 25, and I would do the square root of C squared. And when I do the square root of C squared, I see that this square root and this squared bit cancel out, and I'm just left with C, which is exactly what I'm looking for. And the square root of 25, of course, that's 5. But if that was a nastier number, then we could pop that into a calculator. So we just used Pythagoras' theorem to work out that C over here has to be equal to 5. If we take a look at another example now, we'll do one where the numbers aren't as nice. So let's have a right-angled triangle here. Again, we've got to make sure we denote it's a right-angled triangle by the little square in the corner there. Now we're going to have this side length here as 7, this side length here as 5. Again, this isn't to scale, okay? And we've got our C here that we're trying to find, which is our hypotenuse. Well, Pythagoras' theorem says that a squared plus b squared is equal to c squared. So C is over here, and again, you can sign your shorter sides as A and B respectively. It doesn't matter which way around you do it. So we use our theorem and we say, okay, well, A is equal to 7. So we put in 7 squared. And instead of B squared, we use B as 5. So we get 5 squared, and that is equal to our C squared here. Okay. Now 7 squared is 49, and 5 squared is 25. Okay, and that has got to be equal to C squared. Now 49 plus 25 is 74. So c squared now has to be equal to 74. So we might just write that the other way around. C squared is equal to 74. Okay, now 74 isn't a perfect square number. Okay, it's actually quite nasty. We can't think of a number that multiplies by itself to give 74. So we have to take the square root of both sides, which is what we do here. And by doing that, we get rid of this square term. So we're just left with our c. And if you put the square root of 74 into a calculator, you should end up with something close to 8.6. Okay, so we now worked out that c here is 8.6. So what we've been doing so far is we've been looking at solving for our longest side, our hypotenuse, okay? What we're going to do now is we'll look at a couple of examples where we have to solve for one of our shorter sides, okay? So it might be A or B here. So if we come and do another one, here we have another right angle triangle, okay? So our little right angle in the corner there. And we're going to have 5 here and 13 here. And I want to work out what B is. Okay, so if that's B, then I know that this side here would be my C and this side here would be my A. Remember, the C has to be the longest side. It's my hypotenuse over here. Now, the Pythagorean theorem says that A squared plus B squared is equal to C squared. Okay, now what is A? Well, A is 5. So I can pop that in, I get 5 squared. Now I don't know what B is, I'm still looking for B, that's my goal. So we keep B as just B squared. And my C, well I know that that's 13, so I get 13 squared. Now I can start to get some numbers from this. I know that 5 squared is 25. Now I still don't know what B squared is just yet, but I know that 13 squared, again you could use a calculator, but 13 squared is a handy one to remember, and it's 169. Okay, now I have to use some algebra. So we've built our algebra skills to be able to tackle this problem. Okay, what's with my B squared that I don't like? Well, I've got this plus 25 here. Okay, so if I want to get rid of a plus 25, I can do a minus 25. So I want minus 25 from this side and minus 25 from this side. So these cancel out and I'm just left with B squared. And 169 minus 25 would give me 144. Okay, now if I want to work out what B is, I need to take the square root of both sides here. So the square root cancels my squared, I'm just left with my B. And the square root of 144, you're looking for a number that can multiply by itself to give you 144, and that would be 12, okay? And you can check that in a calculator too. So we've worked out here that B is equal to 12 in this case. We'll do one more example where once again the numbers don't come out as nice, so we don't get a nice round whole number like 12, and it might be a decimal like our 8.6 that we saw before. So one last example, we've got a right angle triangle here with my little right angle in the corner, and we'll let this side length be length A. This is 3 and this here is 14. Okay, so my longest side is the one opposite my right angle, so it's this side here. So 14 is going to be my C. And my 3 here is going to be my B because A has already been denoted for me. Okay, so we're looking to solve for A here. We're looking for another short side. So we know our theorem is that A squared plus B squared is equal to C squared. Now we don't know what A is, so we've got to keep that as just A squared, but we know that B is equal to 3, so I can pop in 3 squared there. And C, I know that C is equal to 14, okay, so I can pop in 14 squared. Now I know that 3 squared is equal to 9, so I get A squared plus, and I get my 9 here, and 14 squared, you can use a calculator and you'll see that that is equal to 196. Okay, now I want to try and find out what A is. So what is with my A that I don't like at the moment? I've got this plus 9. Okay, so how can I get rid of a plus 9? Well, I need to minus 9 from both sides. So I can minus 9 from my left-hand side, which will get rid of these, so that will cancel those out. So I'm just left with my A squared. And 196 minus 9 gives me 187, okay? Now, if I want to work out what A is, then I need to take the square root of both sides. So I can take the square root of this side and the square root of this side, and doing that, we'll get rid of that little squared bit that I don't like. So I'm just left with my a now, which is exactly what I need. And if you take the square root of 187 in a calculator, you should get 13.7. Okay, so this a side here is 13.7 in length. So that's a little introduction to Pythagoras, and hopefully now you're equipped to be able to solve for short sides and long sides of a right angle triangle.